Hey everyone, welcome back to the Can AI Drink Beer channel. Before we jump into Cursor and start building our project, let's spend a minute talking about semantic versioning and why it matters. As projects grow, we constantly add new features, fix bugs, and sometimes make larger architectural changes. Without a clear versioning strategy, it quickly becomes difficult to understand what's changed between releases and whether it's safe to update to a newer version. Semantic versioning solves this problem with a very simple format: major, point, minor, point, patch. Each number has a specific meaning and tells other developers exactly what kind of changes were introduced in a release. The major version represents break-in changes. These are changes that require users to modify their code or adjust how they use the software. The minor version represents new functionality. New features are added, but everything remains backward compatible. And the patch version is used for bug fixes and small improvements that do not change the functionality or public interface of the application. A simple rule to remember is this: if users need to change their code, it's a major version. If you are adding functionality without breaking existing behavior, it's a minor version. And if you are only fixing something, it's a patch version. Instead of managing version numbers manually, we will use custom cursor commands to automate the entire process. Before we finish, all prompts and custom cursor commands used in this video are available in this GitHub repository. Feel free to check it out, download the examples, and use them in your own project. The link is also available in the video description below. So let's jump into Cursor and get started. Alright, we've just seen a quick introduction to semantic versioning and now it's time to see it in practice. We will build a very simple calculator library and use our custom cursor commands to create minor, patch, and major releases. Before we start building the calculator, let's take a quick look at the custom commands we will be using throughout this video. In a previous video, we learned how to create custom cursor commands, and for this example, I've already prepared 3 of them, one for patch releases, one for minor releases, and one for major releases. All of these commands are stored inside that cursor/commands directory. Cursor automatically discovers command definitions from this folder, making them available directly through the command interface. Let's quickly review these commands files and see how they work. As you can see, each command contains a set of instructions that tell the AI agent how to analyze the repository, determine the next version number, create release notes, and generate git tag. For this demonstration, I've removed the push to remote step since we are working only with a local repository. If needed, you can easily add that step back to match your own release process. The nice thing about this approach is that we define the release process only once and then we can reuse it across multiple projects. Now that our custom commands are ready, let's create a simple calculator library and see how semantic versioning works in practice. To keep things simple, I'm going to create a file called calculator.py and implement 4 basic operations: addition, subtraction, multiplication, and division. As you can see, these are just simple standalone functions, but they already provide useful functionality. According to semantic versioning, whenever we add new functionality in a backward compatible way, we should increase the minor version number. So instead of manually creating comments and tags, I will use the custom command we prepared earlier. I will run the version minor command and let Cursor analyze the repository. The agent reviews the changes, determines the current version, calculates the next minor release, and prepare a release summary. Cursor starts working through the release process. You may notice Cursor running several git commands along the way. That's perfectly normal, especially in a newly initialized repository where comments and tags don't exist yet. The agent uses the feedback from each command to determine the next step and eventually completes the release workflow successfully. We will have to wait a minute. Okay, here's our release summary. Now we should confirm that we would like to make a commit. After confirming, our calculator is now officially released as version 0.1.0. Okay, and we can check. Okay, it's here. Now, let's make a small improvement to our calculator. If I try to divide a number by 0, Python raises an exception and the application crashes. While this is technically expected behavior, it's not a great user experience. Instead, I would like our calculator to explicitly detect this situation and provide a clear error message. I will update the divide function to validate the input and raise a more meaningful exception when the divisor is 0. This change doesn't introduce a new functionality and it doesn't change how the calculator is used. We are simply fixing a bug and improving the reliability of the application. According to semantic versioning, bug fixes should result in a patch release. So I will run the version patch command. Just like before, Cursor analyzes the repository, compares the changes with the previous release, calculates the next version number, and prepares a release summary. We will have to wait a minute. Okay, here's the summary. After confirming the proposed changes, Cursor automatically creates the commit and the git tag. Okay, our calculator is now released as version 0.1.1, and you can see it here. For the final step, let's make a much larger change to our calculator. Right now, all operations are implemented as standalone functions. While this works perfectly fine for a small example, in larger applications, we often want to group related functionality together and expose it through a class. I will refactor the code and move all calculator operations into a new calculator class. The functionality remains the same. We can still add, subtract, multiply, and divide numbers. However, the way users interact with the code has changed. Previously, users could call the functions directly. Now they need to create an instance of the calculator class before using its methods. This means existing code written against version 0.1.1 would no longer work without modification. And that's exactly what semantic versioning defines as a break-in change. Whenever a change requires users to update their code, we should increment the major version number. So let's run the version major command. Again, Cursor analyzes the repository, detects the changes since the previous release, calculates the next major version, and prepares the release summary. Okay, here's the summary. After confirming the proposed release, Cursor creates the commit and the git tag automatically. Okay, and our calculator has now been released as version 1.0.0. And that's it. We have successfully created a minor, patch, and major release using custom cursor commands. This simple example shows how semantic versioning can help keep your projects organized while Cursor takes care of the repetitive release tasks. All commands from this video are available in the GitHub repository. Thanks for watching. and see you in the next video.